Okay, so the last thing we need to do is find out the solutions to planes intersecting. Okay, so if you're talking about two planes in space, then you have three choices. So it's pretty simple. Either the two planes intersect, they're parallel to each other, or they're coincident, meaning they're the same plane. They're right on top of each other. If you have three planes in space, then you have a lot more choices. Okay, they could be all coincident. They're all the same plane. You could have two that are coincident, so P1 and P2 are right on top of each other, and one that's intersecting. You could have two that are coincident and one that's parallel. You could have two that are parallel and one that intersects. You could have all three parallel. You could have all three planes meeting in one intersection point. You could have a unique solution there. You could have the three planes meeting along a line, and then you could have the line of intersection of any two being parallel to the third plane. So our goal is going to be to figure out which of these things is happening. In order to do that, you work with matrices. And you should have covered matrices in Algebra 2, but it depends on the year that you had it, how much was done with it. So I'm going to go and just kind of talk to you about a few basics, and I'm just going to kind of point out a few things. This is the pre-cal book. And there's a few ways to work with matrices for solving systems of equations. And one of them is to put them in matrix form and work using elementary row operations. So just kind of a little review. Things that you can do for row operations, you can switch two rows. Okay, so here you see a matrix, and one of the operations that you're allowed to do is that you can switch two rows. Okay, so you see they just moved this whole row to the top and the other row, the first row to the second row. So that's one of the things that you're allowed to do. The other thing that you're allowed to do is you're allowed to multiply a row by a non-zero constant. Okay, so obviously if you multiply by 0, you've gotten rid of your row. Okay, so if you look, for example, at this one, um, and a lot of times our goal is to make our leading number a 1. What they've done is, well, we'd just like to divide through by 2, which is the same as multiplying by a half. So then they just take one row and they multiply every single entry by a half. So that's another thing that's allowed. Okay, another thing that's allowed, and one of the most common things we'll do, is to add a multiple of a row to another row. Okay, so if you look at what they've got here on this side, a lot of times one of the goals that we're going to have, I'll show you here in a minute, is to make this first a 0. So you're trying to have a 1, a 0, and a 0. Okay, well, if you think about how you would do that, you can usually you look to a row above, and if you look at this row, it's a 1 in the top. So if you look at what you would have to do to this so that you could add it to this row and it come out to be 0, well, if you did negative 2 times this row and add it to the third row, you would have a 0 right here in this entry here. Okay, and so that's what they've done. So they said negative 2 times row 1, so that would be negative 2, and they added it to row 3, so that would give you a 0. And then they did negative 2 times 2 is negative 4, add it to 1, get negative 3. They did negative 2 times negative 4 and got 8, add it to 5, they got 13. Negative 2 times 3 is negative 6. Add it to negative 2, they got negative 8. So these are legal row operations that you can do when you're working with matrices. Okay, so let's look at what it is we'll do with that. Okay, so the idea is you're trying to solve equations with three unknowns and three equations. Okay, so what they've done here is they've compared what a linear system would look like and how we would work with that with what's called an augmented matrix. So what you do is you just use the coefficients of x, y, and z. Okay, so that's what they've done, 1, negative 2, and 3, and then over here they put what it's equal to. Okay, so they just put a little line there. Okay, so again you see the coefficients, negative 1, 3, and 0, and then negative 4 over here, and then 2, negative 5, 5, and 17 over here. Okay, now our goal in this whole thing is to get it down to where you see a diagonal of 1s, and then you have 0s here underneath. Okay, and if you do that, that's called echelon form. And if you want to go even further, reduced echelon form is if you also make these numbers 0, so that you have the identity matrix. So if you had the negative 2, the 3, and the 3 also being zeros, that would be called the identity matrix, and you would have put this in reduced echelon form. Okay, so basically it's just a way of being able to manipulate these equations without having to write out the x, y, and z. Okay, so again, remember your goal for right now is to get a diagonal of 1s and these zeros underneath. So if you look at what they've done, they've got the 1 at top, and that's always what you want to do first. So if that wasn't a 1, if it was, say, a 2, then you would just multiply the whole top row by a half. Make sure you start with a 1 in this first entry. Okay. Now the next thing is to get a 0 beneath that. Well, and remember, you can add one row to another row. So that's what they did. They added this row, row 1, to row 2. Okay, and they put the result right here. So if you notice, they left the first row alone. They left the third row alone. But they added row 1 to row 2. So 1 plus a negative 1 was 0. Negative 2 plus 3 was 1. 3 plus 0 is 3. 9 plus a negative 4 is 5. Okay, so they've got one of their goals here that we want. And over here, they're just letting you know that this is the same as if you add the first equation to the second equation, which is perfectly legitimate. That both sides of the equations are balanced. If you add on this side and add on this side, you'll get another equation that is also valid. Okay, so they left their first equation alone and their third equation alone. And if you notice, if you add these two equations, x and negative x cancel. You got no x's there. Negative 2y plus 3y is y, and 3z plus nothing is 3z. So again, we don't have to go through this step by step on this side, but I just wanted you to see that you're basically just trying to parallel operations that you can do with equations and not have to write out as much. It just kind of keeps your work simpler. Okay, so the next thing that the goal after they had this was to make this a 0 underneath. So you're going for the 1, 0, 0 first. So this is a 2, and you're always going to, in order to eliminate something here, you're going to look above it. Okay, so if we look, we're going to go for that 1, and if we wanted to multiply that by something so we could add to this and make this a 0, we'd have to do negative 2 times this, negative 2 times 1, and add it to this, so we would get 0. Okay, so the row operation, and you write row operations to the side, is you do negative 2 times row 1 and add it to row 3. Okay, so they did negative 2 times 1 was negative 2, add it to 2, they got 0. Negative 2 times negative 2 is 4, add it to negative 5, they got negative 1. Negative 2 times 3 is negative 6, add it to 5, they got negative 1. Negative 2 times 9 is negative 18, add it to 17, they got negative 1. Okay, and again, I'm not going to go through this side, but they're showing you the parallel things that you could do on this side. Okay, same thing, only they have to write out x, y, and z. Okay, so now if we look, our next goal is to make this guy a 0. So we're going to look above it and see what we've got. Well, if I just add this row to this row, add row 2 to row 3, that'll come out to be a 0. So that's what they did. They left the first row and the second row alone. Add row 2 to row 3. So this is already a 0. 1 and negative 1 would be 0. 3 plus a negative 1 is 2. 5 plus a negative 1 is 4. Okay. Their next and final goal is going to be to make this guy a 1. So basically you just want to divide by 2, which is the same as multiplying by half. We always talk about, when we're using matrices, we don't talk about division. Rather, we talk about multiplying. So we would just multiply by the reciprocal. So just multiply that last row by a half. And so half of 2 is 1, half of 4 is 2, and you've got it. And that's called echelon form. Well, why is that useful? That parallels, remember these are representing x, y, and z. So if you look at the parallel equation over here, z is 2, 1y plus 3z is 5, 1x minus 2y plus 3z is 9. So what you can do then is you see your first solution, z is 2, and then you can just substitute 2 in for z and solve for y. And then once you know y and z, you can substitute back in and get what x is. Okay, so that's echelon form, and then there's also reduced echelon form. Okay, so if you look, I'm just going to flip over here, they continued this same example. Okay, so let me just show you the difference for reduced echelon form. So we'd already done this. Okay, that's what we just got through doing. And reduced echelon form is if you want to turn this into the identity matrix. The identity matrix is a diagonal row of 1s, and every other remaining spot is 0. And the advantage of this is when you're done, you are really done. This is 1z equals 2, 1y equals negative 1, 1x equals 1. So you've got your x, y, and z right there without any back substituting. Okay, so when we look at this, we already have that. So your next goal is going to be to make this guy a 0. So if you think about how we do that, we're actually going to have to go down a bit to do that. Okay, so I would multiply row 2 by 2 and add it to row 1. Okay, so if you notice, they've left row 2 and row 3 the same, and then they did 2 times 0 is 0, add it to 1, you get 1. 2 times 1 is 2, add it to negative 2, you get 0. 3 times 2 is 6, add it to 3, you get 9. 2 times 5 is 10, add it to 9, you get 19. So we've managed to get that 0. Okay, now this next one, they're going to do 2 operations at once, okay, because they're going to try to get 2 different zeros here. Okay, so let's take a look at, say, making this 3 into a 0. Well, for that, we'd have to go to the row below, and we could do negative 3 times that 1 and add it to the 3. That would give us 0. Okay, so we're going to do negative 3, and here they've written out, times row 3 and add it to row 2. Okay, so the only row they've left alone is this bottom row. Okay, for the middle row, they did negative 3 times 0 added to 0 is 0. Negative 3 times 0 added to 1 is just 1. Negative 3 times 1 added to 3 is 0. Okay, and then negative 3 times 2 is negative 6. Added to 5, you get negative 1. Okay, in the same step, they wanted to go ahead and make this one a 0. So again, they're going down to that bottom row of the 1 and doing negative 9 times that, adding it to the top row. Okay, so you see the zeros won't affect anything on the top row, so the 1 stays, the 0 stays. Negative 9 times 1, add it to 9, you get 0. Negative 9 times 2 is negative 18, add it to 19, and you get 1. And so this gives us our x, y, and z. And this is what we're going to need to do for solving for the equations between or the intersections of planes. And so I just want to give you a little review in case that was not the method that you used in Algebra 2. There are many methods you could have been taught. This is simply one of them.